Hello, I'm Travis and this is Cynthia and we're with Texas Stream Team. Today we're going to be showing you the Texas Stream Team paddling instructional video where we show you how to collect water quality samples from a canoe or kayak. We're going to be showing you the equipment that's going to be used, how to collect that data, as well as some safety precautions that need to be taken. When you're out on the water, always remember to wear your personal flotation device and always travel with a buddy to make sure that both of you are safe at all times. Before you go out, submit a paddling plan to a friend that's on shore. Let them know where you're going, how long you'll be out, and when you'll return. When going out to monitor in a canoe or kayak, be sure that you carry the following equipment with you. You're going to need a 5-gallon bucket. Be sure to have a dry bag with you so that way you can put your phone and your wallet and your keys in it. Always take sunscreen and insect repellent with you. Be sure to have plenty of water available and always have a knife on hand for emergencies. You're going to need to take your clipboard with a pen and your Texas Stream Team data sheet, and you need a rinse bottle with deionized water and a waste container. You're going to be monitoring with one of the two kits that we have. The first one is our traditional Texas Stream Team kit, and this contains all of the equipment needed for the core water quality monitoring that our monitors and citizen scientists use when on land. The second kit that we'll be showing you today is a kit specifically used for the Texas Stream Team paddling program. And this kit contains two electronic probes that take the temperature, pH, conductivity, and dissolved oxygen. And we will be showing you how to use those probes as well. Before you start using your electronic equipment to take water quality data, it needs to be calibrated. And Cynthia today is going to be using the traditional Texas Stream Team kit. So she's going to show you how to calibrate the EC tester for the traditional kit. And this is used to measure the conductivity of the water. So what she has is a conductivity standard, and this was prepared in the lab, and it is a known conductivity value. So our value here is 598. Our conductivity meter only goes up in units of 10, so we want to calibrate it to 600. So the first step she's going to do is rinse the equipment twice with the conductivity standard. You always want to rinse all of your equipment twice before you start taking a sample. And then when you're done, you're going to rinse it twice with the deionized water. So always rinse twice with the sample of water you're going to be measuring. In this case, we're using the conductivity standard. After you've rinsed twice, pour 50 milliliters into the beaker. Turn the conductivity meter on and stir for 2 minutes to remove any air bubbles. So after 2 minutes, you're going to look at the temperature of the standard and record that. And you're going to write down the initial value on the conductivity meter. In this case, the conductivity meter is showing 610. We want to calibrate that to the known value of the conductivity standard, so we're going to lower that value to 600. To do that, you're going to screw the top of the cap off, and there are two white buttons. The white button on the right raises it, and the white button on the left lowers the value. So we're going to lower that value to 600. Once you get it to 600, pause for 2 seconds and the meter will calibrate. Record the value of the conductivity standard that was used, as well as what the meter was adjusted to, on your meter calibration table on your data sheet. A new component to the Texas Stream Team program is the use of the ExStik 2 electronic probes for collecting water quality monitoring. And the reason why we want to do this with the paddling program is because it is easier to collect the water quality data and quicker so that it can be done from a canoe or kayak. But like the conductivity probe in the traditional kit, these electronic probes must be calibrated before going out to collect data. The first one I'm going to do is the conductivity. So I'm going to grab the ExStik to pH conductivity meter out of the kit. And a difference between using this probe and the conductivity probe of the traditional kit is that you have to use a specific conductivity standard. And for this one, we're going to use a 1,413 microsiemens per centimeter conductivity standard. These probes automatically calibrate to that specific conductivity. So this is the only standard that can be used for calibrating this meter. The first step is to pour about 4 milliliters of water into one of the plastic caps provided in the kit and rinse twice. After you've rinsed twice, pour 20 milliliters of conductivity standard into your plastic bottle and turn the meter on. The meter will recognize the conductivity of the standard that you're using and come pretty close to it. In this case, it is registering 1,403 microsiemens per centimeter. We want to calibrate this to 1,413. And this is done automatically. After about 2 minutes of letting the meter stabilize, we're going to hit the Cal recall button. We're going to push this and hold it for 2 seconds, and the number will begin to blink. It will blink at 1,413, saying that that is what the meter has been calibrated to. And it will do this for several seconds, and then an SA will come up on the screen. Once that's done, the calibration of the conductivity has been complete. After you've calibrated the conductivity, you will use the same meter to calibrate for the pH. In order to change the units from conductivity to pH, you're going to press and hold the mode hold button until it switches. Your screen should show pH, and a new number should be up on the screen. Once you're on pH, you're going to take the plastic bottle from the kit and you're going to rinse it twice with a pH buffer solution of 7. So pour 4 milliliters in and rinse the probe. After you've rinsed, pour 20 milliliters in and put the probe in and let the number stabilize for 2 minutes. After 2 minutes, you're going to press the Cal recall button and hold it until that number starts blinking, and it will calibrate to 7. After it has stopped blinking, it has been calibrated. Record the temperature of the standard that was used, as well as the initial reading of the pH on your data sheet. The last calibration that needs to be done with the ExStik meters is the dissolved oxygen probe. This is a separate meter from the pH and conductivity one. So pull out the one that says dissolved oxygen and turn it on. It needs to stabilize for 3 minutes in the on position before you calibrate. After 3 minutes, press the mode hold button until the oxygen is read in % saturation. There will be a little % sign underneath the main number on the screen. When you're there, you're going to press the Cal recall button and hold it. The number will switch to 101.7 and blink for several seconds, and then an SA will come up, followed by an end. When that happens, the probe has been calibrated and is ready to take measurements. All right, well, Cynthia and I are now at our site, and the first thing you want to do when you get to your site is to make sure that it's safe. So check around and make sure that there's no boat traffic in the area. Also make sure that you're not in an area of fast current that's swift and will take you off while you're trying to do your data collection. And also, if you're in a moving river, make sure that there are no log jams or rapids downstream of you before you start monitoring. So the first thing that we're going to do when we start collecting our data is that we're going to collect our field observations. And what I have here is the blue thermometer in the kit, and I'm just going to hang this off of my clipboard while I do these field observations. And a good thing about the buddy system is that you can have one person be the recorder and the other person taking all of the water quality data, which Cynthia is going to be doing with that kit. The first field observation is flow severity, and it's on a scale of 1 to 5, 1 being no flow, 2 being low, 3 is normal, 4 is flood, 5 is high, and 6 is dry. And what we're looking at there is not so much the flow of the water, but the level of the water. So you want to look around at the water line and see if it is at its traditional level. And you're going to become more familiar with that the more often you go out to your site. So when I look for low conditions, I look to see if there is a high water mark on the bank where the water line traditionally is. And if the water's high, I'm going to look and see if there's going to be vegetation in the water that normally isn't, like grasses or trees. Looking around here, it looks like the water level is typical for this area, so I'm going to mark that as 3 normal. The next one is algae cover, and again it's on a scale of 1 to 5, 1 being absent, 2 being rare or less than 25%, 3 is common, 4 is abundant, and 5 is dominant. And these are based on percentage coverage. So a 5 dominant means that there's greater than 75% of the area is covered in algae, or abundant is 51 to 75%. Common is 26 to 50%, and rare is less than 25%. Looking around here, I would say that this is not dominant, but there is quite a bit of algae out here. So I would say that this is either a 3 or a 4. A 3 for common or 4 for abundant. And I'm going to say that this is abundant, so I'm going to mark this a 4. For water clarity, there are 3 choices, and that is clear, cloudy, or turbid. Cloudy water would be kind of a chalky white color, whereas turbid would be more of the chocolate milk looking color. So looking at this water is pretty clear. We can see pretty far down here, so I'm going to mark that a 1. The water surface, our options are a clear surface, scum, foam, debris, or sheen. And when we talk about scum, that is like a thin film across the water surface. Foam would be more of this pillow, billowy, white foam that would be on top. Debris would be trash, but it can also be natural debris such as riffraff or log jams or anything that has moved into your area that typically isn't there. And sheen is a rainbow looking color on the surface of the water, and that's indicative of oil, of the presence of oil in the water. So looking here, the water is pretty clear, so I'm going to mark that as 1 for clear. The water conditions, the options are calm, ripple, waves, and whitecaps. And looking out here, calm is a very rare choice to select. That is on days when there's absolutely no wind and the reflection of the water is just showing, you know, the trees in the background. It's almost calm today, but your more common choice will be ripples, and there's a little bit of wind and a little bit of ripples on the water, so we're going to mark that as 2 for ripples. Present weather, our options are clear, cloudy, overcast, and rain. And we mark it clear when there is absolutely no clouds in the sky. If you see even one little white cloud, then we're going to mark it as cloudy. And the difference between cloudy and overcast is that on a cloudy day that you would actually see some of the blue sky. So today there's actually no blue sky. This is complete overcast. We'll mark it a 3 for overcast. We also want to find out how many days it's been since significant precipitation. The best way to do that is to go to a website such as weather.com or Weather Underground and look up the archival information for the area where you're sampling. It will also show you the rainfall accumulation in the last 3 days for your area, and you can mark that there as well. After recording your field observations, you can take a look at your thermometer and measure the air temperature. And the air temperature here looks to be about 18 degrees centigrade. So we're going to mark that for air temperature. In order to do the last 2 field observations, the water color and the water odor, it's best if you have the sample actually in your bucket. And this is why we brought the 5-gallon bucket with us. It's also easier for us to take water out of the bucket for our sampling rather than sticking our equipment over the boat where we could possibly lose it. So that's why we carry the 5-gallon bucket with us. To collect your water sample, we're going to first pour water in here and rinse the bucket twice. And be sure that you are rinsing and dumping the rinse out in the opposite side of the kayak as where you're going to be collecting your sample, because you don't want to stir up the water. Also, if you're in flowing water, make sure that you're discharging that water downstream. Another reason why we want the bucket is because we're actually taking subsurface water samples. And so the water quality up at the surface of the water is going to be different than what is slightly below the surface. And so that's why we want to take this at about a foot below the surface of the water. So the way we do this is we hold the bucket over the kayak like this, and we're going to let the air out by tilting it. We're going to get the bucket down to the top of the lid so that it is pretty much submerged like this. And we're going to lift it up, and then it's pretty heavy when it's filled with 5 gallons of water, so we're going to dump about half of that out, and then you can lift it up into your kayak. So another good reason why you would have the buddy system is that one kayak can hold the sample in the bucket while the other person has the traditional kit open and ready to start doing the water quality. So that's what we'll be doing here. So I'm looking in the bucket right now, and I'm looking at the color of the water. And our options for water color are no color, light green, dark green, tan, red, a greenish brown, and black. And looking in here, I can see that there is no obvious color to the water, so I'm going to mark it as 1 for no color. Then for odor, what you want to do is take your clipboard and kind of waft the water over, and if you can't smell anything, then you're going to want to get in close and try and smell. And our options for water odor are none, oil, an acrid pungent smell, sewage, rotten egg, fishy, or musky. And so there was no obvious odor to the water here, so I'm going to mark it 1. And in most cases, you will get a 1. The next measurement that you're going to take is the Secchi disc depth and the total depth. And so for that, we have what's known as a Secchi disc. A Secchi disc is a hard plastic round disc with a black and white pattern on it and a line attached to it. This is a very simple oceanographic tool used to measure water clarity. You use the Secchi disc to measure your water clarity by simply lowering it off the side of your kayak until you can no longer see the black and white pattern anymore. And so Cynthia is lowering it down right now, and it has gone all the way down to the bottom, and we can still see it. So once it is gone till you can no longer see it or it reaches the bottom, mark that line, that spot on the line with your hand and begin retrieving it. So our Secchi disc line has black marks indicating 1/2 meter and red marks indicating 1 meter. So we're going to bring that up, and that's 1.5, 2.5, 3.5, 4.5 meters. So I will mark that as the Secchi disc transparency. So because the Secchi disc transparency went all the way down to the total depth, we actually don't know what the water clarity maximum depth is because we ran out of room. So in this case, we will mark a greater than 4.5 for the Secchi disc transparency depth on the data sheet. Since the Secchi disc went all the way down to the bottom, we can use that as the total depth measurement as well. Our total depth measurement is 4.5 meters. Now we're going to take the conductivity reading. And to do that, we have our conductivity meter that we calibrated on shore and our beaker. And the first step is to grab some of the sample and rinse the beaker and the meter. And we're going to do that twice. And when you're done, pour it into your waste container. After you've rinsed twice, go ahead and grab about 50 milliliters of sample, turn your conductivity meter on, and put it in. I'm going to hand that off to Cynthia, and she's going to stir it for 2 minutes until the conductivity reading stabilizes on there. After 2 minutes, you're going to take your reading. And to take your reading, you're going to hold the meter in the middle of the water column so that it is not touching the sides or the bottom. And once you've done that, you look at the reading, and I'm going to record what she has on there. And
620.
so the reading is 620 microsiemens per centimeter for conductivity. We can also take water temperature with this meter.
21.4 degrees.
And the water temperature was 21.4 degrees Celsius. After you've done taking your reading, turn the meter off, and you're going to dump the water out into the waste container. And you're going to rinse the meter and the beaker off with the distilled water.
For the pH test, the traditional kit uses a wide range indicator reagent. So we're going to take the test tube in the kit and rinse it twice with the sample water from the bucket. Then we'll fill the test tube up to the black line that is on the tube. Next, we'll pull the wide range indicator out of the kit. Now we'll invert the test tube and add 10 drops of wide range indicator into the test tube, making sure the test tube is completely inverted and that no drops touch the sides of the test tube. This makes sure that all the drops are uniform in your sample. Now we'll insert the blue cap into the top of the test tube and invert the test tube 10 times, like so. After inverting 10 times, we'll take our two color comparator boxes out of the kit. One of them has a reddish pinkish tint and is for acids and solutions with a low pH, while the other has a greenish bluish tint and is for samples that are neutral to basic. This sample appears to have a greenish tint, so we'll use the neutral to basic pH comparator. Next, we'll pull the test tube in one of the two holes at the top of the comparator that corresponds closest to the color of the sample. In this case, we put the test tube on the left side because the sample is closer to green than blue. Remove the blue cap from the test tube, as the blue in the cap can affect your pH reading. Use the field reference sheet with a white background so you can get an accurate reading. Now we'll look at our color comparator and determine which of the numbers matches our sample the closest. In some cases, the reading may be between the number intervals shown on the comparator, so you may need to estimate to the nearest tenth. For example, if a sample is between the green 7.0 and darker green 7.5 values, then we can say it's 7.3. In this case, our pH is right at 7, and we'll record that on our data sheet. After we're done taking your pH reading, we'll take the sample and dump it out in the waste container. Rinse the test tube with your distilled water and put your test tubes back in your kit. The next measurement we're going to be taking is dissolved oxygen. Measuring dissolved oxygen with a traditional kit involves a process called titration. It's a several-step process that involves adding several chemicals, including sulfuric acid, into the bottles. So for safety reasons, we're going to just collect our sample water at our site when we're in the kayak or canoe and do the titration on shore to complete the process. To collect the sample, we have two DO fixing bottles in the kit. We'll take the caps off the bottles and rinse them twice with the sample water in the 5-gallon bucket. After we've rinsed the bottles twice, we'll fill each bottle up with the sample water. It's important not to leave any air bubbles in the sampling bottle, as that can affect your DO reading. The best way to do this is invert the bottles into the water and then turn them upright while they're still in the water in order to let all the air bubbles escape. We'll then cap both bottles while they're underwater and pull them out, checking to make sure that there are no air bubbles. Make sure you take a 5-gallon bucket with you to do your DO sampling in a canoe or kayak, as it's not a good idea to try and sample from the side of your boat. You could lose your bottles and caps, or worse, flip your kayak. Next, we'll put our bottles back into our kit and do the next DO measurements on the shore.
Next, we'll show you how to sample all the parameters that you took with your traditional kit while using the ExStik 2, ExStik pH conductivity, and dissolved oxygen meters. This is used for the Texas Stream Team paddling program because it's a compact kit with only 2 meters and it can be used quickly and easily, so you don't need to use reagents or add chemicals to your sample in your kayak. First, we'll measure pH, conductivity, and water temperature by using the ExStik 2 pH and conductivity probe. We're going to grab one of the plastic vials in the kit, rinse it twice, and put about 20 milliliters of sample water into the vial. Next, we'll press the on button on the ExStik 2 and place it into the plastic vial. We'll do the conductivity first. Press the mode hold button and hold it until it cycles through everything. You'll know you're on conductivity when you reach the microsiemens unit. The unit is indicated by the Greek letter mu followed by a capital letter S. You'll have a number down below that unit, and we'll let it stabilize for 2 minutes until we have our number. After it's stabilized, we'll record the number for conductivity on our data sheet. Under that number, you should see the water temperature, and after your probe is stabilized, you can record that temperature value as well. In order to take our pH reading, we'll use the mode hold button again and let it cycle through the units until it gets to pH. Now we're on pH. Since our probe has already been in the water for 2 minutes, we don't need to let it sit for that long again, and we'll just let the number stabilize. After you've done that, you can take your pH reading from your ExStik 2 probe. Now we'll finish up by rinsing the ExStik probe twice with distilled water. The next parameter we're going to measure with the ExStik meters is dissolved oxygen. To do that, we'll grab the ExStik dissolved oxygen meter and a wide mouth plastic beaker. We'll fill the beaker up with sample water and rinse that meter twice. After we rinse, we'll grab 50 milliliters of sample water and put the probe into the beaker, turn it on, and stir it. There are several units used to measure dissolved oxygen on this probe, but we want to measure it in milligrams per liter. And when we calibrated the probe, it was on % saturation mode. So what we want to do is change that to milligrams per liter by pressing the mode hold button and cycle through the unit until you see the correct value. Next, we'll stir the dissolved oxygen meter for 2 minutes and let the number stabilize. This number can fluctuate a bit, but we want it to fluctuate between 1 milligram per liter of dissolved oxygen. Right now, we have it stopped at about 6.19, so we'll take that as our measurement. Go ahead and turn your meter off, discard your water in the waste container, and rinse your beaker and probe twice with distilled water.
Are both of your samples that were taken from the canoe or kayak. Our first step is to unscrew the caps from these sampling bottles and put 8 drops of a reagent called manganese sulfate into each bottle. The next step is to add 8 drops of the alkaline potassium iodide reagent. You should start to get a brownish yellowish precipitate forming after you add the alkaline potassium iodide. After you've added both chemicals, we're going to cap both bottles and invert them 25 times. Now, after inverting the bottles 25 times, we're going to let the precipitate settle below the shoulders of the bottle. After the precipitate has settled below the shoulders of the bottles, we'll invert them again 10 more times. And then let the precipitate settle below the shoulders once again. Once the precipitate has settled again, we're going to unscrew both caps and add 8 drops of sulfuric acid to each bottle. Then we cap both bottles and invert them until the precipitate has dissolved and you have a dark yellow solution. Once the precipitate has dissolved, we're going to uncap the 2 bottles and take out our 2 titration vials. We'll now uncap both of the vials. There's one vial per bottle of solution, and we're going to rinse both vials twice with a small bit of their respective solutions. After rinsing, fill each vial with its respective solution with 20 milliliters of the sample. Now be sure and cap your sample bottles in your titration vials. To do your titration, you need a titration syringe and your solution of sodium thiosulfate. Fill your titration syringe with 10 units of thiosulfate by inverting the bottle with the syringe in it and pulling the plunger until it goes to the 0 line at the top of the syringe. The first time you extract the thiosulfate out of the bottle, you may get an air bubble in your syringe. If you get an air bubble, tap the titrator until the bubble goes up to the pink titration tip and depress the plunger until the air bubble escapes. Then withdraw the plunger until your syringe goes back up to the 0 line again. Once you have your titrator vial filled with the sodium thiosulfate, we're going to take one bottle and add sodium thiosulfate to it. Add the thiosulfate 1 or 2 drops at a time until your solution turns a pale light yellow color. Once the solution has reached that color, we're going to lift the vial cap off, keeping the syringe over the solution so that nothing spills out, and we're going to add 8 drops of starch indicator solution. The starch indicator solution will turn the sample into a dark purple color, and we're going to continue titrating by adding 1 drop at a time of sodium thiosulfate until the solution turns clear. As soon as the solution turns clear, we're going to stop the titration. Once the solution turns clear, we're going to look at the syringe to see how much thiosulfate was added. The increments on the syringe are in 0.2 milligrams per liter for each line, and the amount of thiosulfate left will correspond to the amount of dissolved oxygen that was in our solution. In this case, it's resting on 4, so the oxygen sample was 4 milligrams per liter. We're going to record that in the first titration box on the data sheet, and we're going to repeat the process for the second bottle and take the average of the 2 results. Again, the second titration was right at 4, and we're going to record that on the data sheet as the second titration, and you take the average of the 2. That is your final dissolved oxygen ratings in milligrams per liter. If the 2 titration values are not within 0.5 milligrams per liter of each other, then you need to redo the titration. After taking your titration reading and recording it, we're going to empty all of these bottles into the waste container and rinse with the deionized water.
And that concludes how to use the TextureStream Team traditional kit, as well as the ExStik electronic probe kit, to take water quality samples from a kayak or canoe. We hope you enjoyed watching this video and have a great time on the water.